Hello everyone, welcome back to Algebra 1 with Miss Betsy. We're nearing the end of Chapter 6 where we're talking about functions, relations, and how to graph the equation of a straight line on a Cartesian coordinate system. What we're talking about today is using the point-slope form of linear equations. This will allow you to graph any linear equation if you have any point. Doesn't have to be the y-intercept, and as long as you know the slope of a line. I happen to be using Algebra 1 for Christian schools. It's published by Bob Jones University Press. I'm using the second edition. If you're tracking with me, we're section 6.7, page 252. But if you just want to know about the point-slope form of a line, go ahead and come along for the ride because the material is the same. Lame joke for the day, still in my piggy book. Where do piggies ride the bumper cars? That's pretty scary in itself. Well, of course, they ride the bumper cars at the amusement park. Just like what you get when you cross a dinosaur and a pig, you get Jurassic Park. So let's go ahead and look at Chapter 6.7, point-slope form of the lines. And what we're doing as we progress through our work with linear equations is we're finding out that as long as we're given specific information, we need to be able to come up with the equation of a straight line. We can do that if we have the slope of a line and the y-intercept. We can do it if we have the slope of the line and any point on that line. And we can also come up with that same equation if we only had any 2 points on the line. Well, first off, let's look at number 1. If we have the slope and y-intercept of a line, then boy is it really easy to write the equation of that line. Example 1 says find the equation of the line with slope, which is m, is equal to 2/3, and y-intercept, which is b, equal to 0, 5. They're going to tell you slope, but you know that that's m. They're going to tell you y-intercept, but you know that the y-intercept is indicated by b when we have the slope-intercept form of the line, which is y is equal to mx plus b. We now have values for m and b. All we do is substitute those in. Y is equal to 2/3 times x plus, b. But we've got an ordered pair here. Do we do the 0, 5 or the 5? What do we do? Well, remember that the y-intercept is the y-coordinate. There's no arithmetic, no algebra to do here. Y is equal to 2/3 x plus 5. So if you're given the slope of a line and the y-intercept, you substitute in for m and b, and that's all you have to do. Don't have to do any more manipulation. This is the equation of a line that intersects the y-axis at the point 5 and has a positive slope where for every 2 units you go up, you move 3 units to the right. So you could very quickly graph this equation on a Cartesian coordinate system by using point-slope form. Now, however, how in the world are we going to do it if we say slope at any point? Because we said that the y-intercept form of the line, we could only use the point where x is 0 and y is whatever the value is where it hits the y-axis. Well, what we do in our book here, they're going to show you how you can use slope at any point of the line. It's a little bit of a technical proof by illustration of how you come up with this equation. Let me go ahead and take you through it. Don't expect you to be able to replicate this, but I do want you to at least see how we come up with the point-slope form of a line. So what we're going to do is we're going to say this any point. We don't know what that any point is, but we're just going to call it the point x sub 1, y sub 1. And that is just any point. And how are we going to come up with slope? Well, this says we're going to substitute another point, x, y. This is just another point. Just a random point. Remember, on a line there are an infinite number of points. So this is going to just be any point. And this is the second point that we need. And why do we need to have those 2 points? Because we can calculate our slope then, can't we? So if we have slope, what's our slope? The slope was the change in y divided by the change in x. You had to have 2 ordered pairs. We have 2 ordered pairs here. One of them we're just calling x and y. One of them we're identifying as x sub y, x sub 1, and y sub 1. And we're going to have this be point number 2, and this be point number 1. And we're just going to substitute in so that we can calculate our slope. So m is going to be, what's the y coordinate of our second point? It's just y minus, what's the y coordinate of point 1? It's y sub 1. Y minus y sub 1. Similarly, we have x minus x sub 1. Okay, so this right here tells us what our slope is. Now, what do we want to do? Well, we don't want to have any fractions here, so we're going to multiply both sides of this equation in just a moment. They're skipping a step, and I really don't want them to skip this step just yet. Do you remember that you can multiply cross products? Hang with me here. What's this going to give me? M times x minus x sub 1 is equal to y minus y sub 1. Do you see that right there? Cross products here. And what they're actually doing is going through a little bit of a difference where they're going to multiply both sides by this fraction here to clear the equation fraction. But all I did was multiply cross products. You use this when you were finding equivalent fractions back in pre-algebra. So we have m times x minus x sub 1 is equal to y minus y sub 1. Sounds really strange, doesn't it? Well, what if we just flip this equation around? Both sides are equal. So we can say y minus y sub 1 is equal to m times x minus x sub 1. This is sort of like where we're solving for y, isn't it? We at least have the y's on the left-hand side of the equation. We have the x's on the right-hand side of the equation. And this is actually what we're looking for. This is a rather messy-looking equation, but this is what they're going to call the point slope form of the line. It's called the point slope form because we have any point which is represented by the coordinates x1 and y1, and we have the slope of the line. Okay? What I'm going to do now is say, if you followed that at all, it's fine. If you didn't follow that a whole lot, go ahead and look at what they've done in your book If you still don't understand exactly what they've done, that's all right, because what you really need to be knowing is that if you are going to be able to give the equation of a line with a slope at any point, you are going to use the point-slope form of a line. Form of a line, which is this: y minus y sub 1 is equal to m times x minus x sub 1. Okay? This is what they call the point-slope form of a line, and you can use that very, very easily to calculate or to come up with the equation of a line given these two pieces of information. And if you're still sitting there scratching your head, don't worry, you don't have to record, don't have to pause the video yet. Let me just show you one of these. I'm going to do example 3. And this tells us to find the equation of the line that passes through the point 1, 5 and has a slope of 3. The point 1, 5, and it has a slope of 3. What I've done right here, this is example 3 on page 253. This is the relevant information. Your problem says, find the equation of the line that passes through the point 1, 5 and has slope 3. Slope is m, which is 3. The point that we're going to use is represented here by the ordered pair 1, 5. All we have to do is substitute this information into our point-slope form of the line. Your very first step that you're going to be is to write the point-slope form. Y minus y sub 1 is equal to m times x minus x sub 1. This point right here, the point that they give us, is where we get our x sub 1, y sub 1. So we have y minus 5 is equal to slope here, which is 3 times x minus 1. Go ahead and I'm going to change this parentheses into a bracket here so that I can close my x sub 1 value in parentheses. Doesn't matter for this problem because our values are positive, but if this had been a negative, it's easy to lose your negative signs, so if you do your substitutions with parentheses, you'll be further ahead. Y minus 5 is equal to 3 times x minus 1. Well, we have to distribute our 3. Y minus 5 is equal to 3x, 3 times x, 3 times negative 1, minus 3. We're getting closer. Y minus 5 is equal to 3x minus 3, but this is not sufficient. Let's take this into the slope-intercept form of the line. This is an acceptable final version of your equation, and that's where we have solved for y. In order to solve this equation for y, what do? We add a 5 to both sides of the equation. Y is equal to 3x plus 2. Now, we have a form of the line. We've an equation of this line. The form that it's in is the slope-intercept form of the line. If I had drawn a graph for you, you could then go ahead and immediately draw this graph on your paper. 1, 2, 1, 2, 3, 3, 4, 5. The y-intercept is the point 2. It has a slope of 3. 3 over 1. 1, 2, 3 over 1. There would be your second point. You would use your straight edge to connect those dots, and you would be able to sketch the graph of your line very quickly. This right here was just my extra for you. Not asking you to do that in this problem. They simply wanted you to be able to take the slope of a line and a random point, use the point slope form of a line to substitute those values in, manipulate your equation so that you're able to come up with the slope-intercept form of a line as your final answer. So let's go ahead and do another problem. Get you a little bit more practice on this. Write the equation of the line that has slope of 1/2 and goes through the point passes through -3, 2. They want us to have the equation of this line. Our slope is given to us. It's a positive 1/2. Means the line is increasing because the slope is positive, and it passes through the point -3, 2. Now what we love to be able to do is to use our slope-intercept form, because then we just plug those numbers right in and we've got our answer. Is this the intercept? No, this is not the y-intercept because x is not 0. So this is just a random point on the line. In order to be able to come up with the equation using these pieces of information, we have to use our point slope form of the line, and this is what you have to write down for me because this will help you to memorize your point slope form of the line, and it will also give you something here that you can clearly substitute. Okay, what's our y value going to be? Our y sub 1 value is 2. Our m is 1/2. Our x is -3. So we have y minus 1/2 is equal to m -3 times, is m -3 and y minus 1/2? No. I used to stop doing the videos at times when I made mistakes like this, but I'm deliberately leaving these in so that you can see that it's easy to get distracted when you're working, or you're not paying enough attention to what you're doing, or you get going too fast, or you've got your iPad in front of you or your iPod in your ears and you're not paying attention and you're doing the wrong substitutions. Y minus y sub 1, that's the y value of our point. Y minus 2 is equal to m, which is 1/2 times x minus the x value. Right here is a good example. Remember I told you just a few minutes ago, make sure you show your substitution in parentheses so you're not dropping negative signs. Y minus 2 is 1/2 of times the quantity x plus 3. We're going to have to distribute our 1/2 y minus 2 is 1/2 x plus 3/2. 1/2 times 3 is 3/2. What are we going to do here? We still need to solve for y. Y minus 2 plus 2 is equal to 1/2 x plus 3/2 plus 2. Y is equal to 1/2 x. How are we going to add 3/2 plus 2? That's not 3.5. We're going to change our 2. We're going to rename that You do not need to show all of these extra steps here if you understand what I'm doing with the fractions. So that y is equal to 1/2 x plus 7/2. It's very easy to find the equation of a line. Sometimes you have a little bit of algebra that you have to do to distribute, use your fractions. But you were just given two little pieces of information. You were given the slope of a line, and you were given any point on the line. You substituted those values, the m, the x sub 1, and the y sub 1, into the appropriate values here in your point slope form of a line, did your algebra, came up with your final answer here in slope intercept form of the line. And if we asked you to sketch this, it would be easy. You would go to the point 7/2 on the y-axis, go up 1 unit, over 2 units to the right for your second point, and you'd be able to sketch the graph of your line. This is what you've been learning in section 6.6 or 6.7. 6.7. So keep playing around with that. You'll be able to do a good job with it.